1 second. Okay, hello. So I apologize for the ridiculous length of the title. I really couldn't think of anything shorter. And so just to give you some context, this talk comes from my previous life, doing this Scala Center thing and kind of having to go around to lots of different companies and try to I was in charge of an open source foundation, but I was talking to them about what many of the issues were that they were having. And I got a lot of these insights sort of slowly through a lot of these interactions with various companies. And then what's ridiculous was that there's a bunch of data, of course, to back it all up, but it's all completely independent of sort of some of the overarching points, how it all comes together. So this is not like, the world's greatest collection of data points or anything. It's a number of data points that, are all out there and available for you to look at, and it kind of paints an interesting picture for us to sort of think about as either educators or people who work in industry on software, right? It's all rather important. So, like I said, I founded this thing called the Scala Center back in 2016, and I sort of bootstrapped it and got it off the ground. I got my PhD in computer science from EPFL under Martin Rudowski working on Scala in 2015. And I did a lot of things related to concurrency, asynchronous programming. I basically got a PhD in the type class derivation and implicit magic. So if you ever have questions about that, I'm sorry that I ever indicated that was a good idea. I work on programming models for distributed programming. Did a bunch of MOOCs on Coursera. Did a bunch of these things, but as you can see, in terms of my academic work, none of it is really about the topic of the talk, right? And since then, I've joined CMU as an assistant professor, but sort of in this period of time between my PhD and joining CMU and going full-time academic, I was doing this Scala Center business, and that's where I got a lot of this info. But yeah, so just to give you, a disclaimer, my research area is actually building and formalizing language-level distributed and concurrent programming abstractions and all kinds of things from monotone computations that are distributed all over the place to, even runtimes. But anyway, yeah. So these are the people I work with, and how did I get these insights I'm going to ramble about for a little while today? Like I said, I was a PhD student. I was working on concurrency and asynchronous programming and terrible implicit magic, right? And then all of a sudden I'm in charge of this thing called the Scala Center, and my focus is then more than 200%. Okay, open source Scala. How do we keep it not dead? How do we keep it alive? How do we do what needs to be done in order to make it useful for companies? And how do we get the money that we need to pay for the development that we need to keep this thing going? And the goal was really to put money into the language, to put development into the language, and really to focus not just on the people who gave us the money, but literally 100% of the people that with an internet connection that could use Scala. It wasn't about hey, Twitter gave us money, so therefore we're going to help Twitter. It was really, what can we do for the largest number of people? And what happened was, I once I had to focus on this one, full time for my job, I quickly found or quickly observed that there's all kinds of problems. Of course, in terms of the health of open source, but also just all of the people that are kind of coming into our community and how software gets built. It's all changing very quickly, and I think that as academics often, we sort of lose sight of this, especially how quickly some of these things are changing. I mean, in industry, it's hard to keep up with these things. So, at that time when I started doing this job, I started collecting some of this data on some of these things that I noticed changing, and I can put it into 3 categories, which is why the title of the talk is so terribly long. I swear these things affect each other. So the first one is, how do we build software nowadays? Like, what do we actually do when we sit down to build an app? And by app, I mean, not necessarily like some distributed system that's meant to be reused by everybody on the planet, but like just an app, like, a web app or a mobile app, or just like, the piece of software that there are users in your company that need to use, right? Like applications. Open source, so, the common infrastructure and tools that we all depend on. Things are changing really quickly in that world. And then what we even think a software engineer is changing, and it's amazing. And I don't know why we're not paying attention to this more. Basically, who they are, what do they know, how much experience do they have? And so I'm going to go through a bunch of really quickly changing trends, like in the last 5 years in these 3 areas. And at the end, I'm going to bring it all together. So the first point that I'd like to make is, how people are getting into tech is changing. I think it's pretty uncontroversial to remark that, we know that hiring is difficult. So, if you're a student graduating, that's great news for you. But if you're somebody who's trying to build a team of developers from scratch, this is terrible news. We all know it's really hard to hire. There are zillions of articles about this all over the place. You probably should have majored in computer science. But it's everywhere. It's not something we're not aware of. But so this is a US-centric view, but I actually started trying to put in one graph a bunch of data that I've gotten from various locations, mostly the Department of Labor and Statistics. So they've been collecting over the years, and also the Department of Educational Statistics. These are US governmental institutions. And what they've been doing is they've been collecting the number of CS degrees or CS-related degrees that have been being graduated from American universities. So it doesn't have to be a bachelor's degree in computer science. It could be like a bachelor's degree in information technology or something. It's just in the category of computing. This is the number of people graduating with these bachelor's degrees every year in blue. So this is, these are recorded numbers, right? And, you can see that, in the early 2000s, it peaked at around 50,000 people graduating or more, 60,000 people graduating per year. Of course, dot-com bubble, now we're down, then it went down below 50,000. And since then, it's been steadily climbing. The rate of growth, so yeah, this is actually the last number that the Bureau of Educational Statistics has put out. There's like a 3-year delay for whatever, 2 or 3 year delay on these statistics being published. But there's about 60,000 degrees that have been awarded in the 2014-2015 school year. And, the last few years, there's been a growth rate of about 7.4% per year. So if you just kind of project that forward, assume we're going to grow at the same rate, this is what it would look like if, like I said, 7.4% per year. We can, by 2026, which is an important number, we can look forward to almost 150,000 people graduating from American universities with some sort of computing degree. Yet another, so this number came out of the Bureau of Labor and Statistics. Basically, they have published in 2017 that there were 500,000 open computing-related jobs that were unfilled in the U.S. at that moment. That was in 2017, which is basically off the chart. So let's pretend that people didn't get hired after they graduated and we could just stack them up and put them in this bar. It would take several years of graduates to fill that up, right? And then, okay, well, what about code boot camps? Those are a thing that are really popular, right? A lot of people are doing that. And there are lots of coding boot camps, 3 months, 6 months, 1 year coding boot camps. Basically take somebody who has some kind of drive to become a software developer and give them the basic skills that they need to be able to get an entry-level programming job. These jobs are growing at a rate of about 14% per year, and there are a number. So this is actually kind of a difficult group of numbers to collect. But basically, the coding boot camps are starting to be organized finally now, and there is about now there's a sort of a better attempt at collecting statistics from these. But right now, the growth rate per year of coding boot camps is about 14%. And again, if you want to project forward, you can say, okay, if I want to know how many people in the U.S. came out of a coding boot camp or a bachelor's degree, we can say, by 2026, we're going to have close to 200,000 people graduating per year. So still a majority of our qualified software developers are coming out of bachelor's degree programs, but the coding boot camps are making a huge dent in sort of the pool of people that could be hired as software developers, as entry-level software developers. But what's completely crazy is that this is another statistic published by, again, the US Bureau of Labor and Statistics. This is the number of software professionals they expect, companies to, software, job openings unfilled in 2026. So if you just take all of those other numbers and then you plot this right next to it, I mean, obviously it's ridiculous, right? Like, let's pretend again we don't have anybody ever getting jobs after they get out of college. We can take all of these people and like stack it up. We're not going to be able to fill that bar, right? So that's completely crazy. And I mean, all of these numbers, like, I'm not making them up. It came from this citation here, and also from this National Women in Technology. I forget the name of the organization, but there's a statistics sheet right there. So it's pretty incredible, right? That 2017, we're at like 500,000 people, or 500,000 job openings that aren't filled, right? And then apparently we're going to get up to 3.5 million by 2026, just based on how the economy in the US is going. So that's completely shocking and ridiculous. And the only reason why, one more point, is that, no matter how hard we try, it's estimated that only 19% of the jobs, so again, this comes from this here, only 19% of these jobs are estimated to be able to be filled by people who come from computing-related bachelor's degrees. So that's, like, what, this much, right? On a good day. So this seems to be a problem, right? I'm not just, like, trolling around and grabbing statistics for no reason. This is something that people have told me when going around and having to talk, about how easy it is for the newcomers, the new hires at companies to learn. People were complaining that there were more and more people getting hired with less and less experience, and it's harder for them to take the terribly crappy developer documentation that we have in Scala and actually become productive engineers with it, right? And, I kept on hearing this complaint. And then, not just related to Scala, I've heard that, onboarding is getting harder and harder and companies are investing more money in it. And I mean, it's obvious, like, why? There's a lot of people that are coming into our field. At least this is going up quite a lot, right? And then, of course, we're going to have even greater needs, apparently, according to the US Bureau of Labor and Statistics. You can also see this in developer surveys from Stack Overflow. So it's really hard to compare all of these like next to each other year by year because they have different like buckets, right? So if you look, this is the developer survey from 2017. All three of these questions are the same. They're asking how many years have you been coding professionally? So like you're employed, A, and B, how many years have you been doing it? And so, 2017, 50% of people had up to 5 years of experience. And if you want to break that down, 32% of those people had three years of experience or less, right? And this is out of almost 40,900 responses. You can't see it, sorry. And then 20% of those, so this is an interesting number, 20% of these people had 2 years or less of experience. So as you can see, it's like all top-loaded here, like in the most people are at this end of the chart. And that's the same for all of these, even though the buckets are a little bit different. So by 2018, 57.5% of people who responded to the survey had up to 5 years of experience. So this is 77,900 people. And in 2019, 41% have less than 5 years of experience. I can't see how many had, including 5 years, I'm sorry. But what's interesting to note here is, in 2017, 20% had 2 years or less. But in 2018, 30% had 2 years or less. Like, that number is getting bigger, right? And this is not, going to go away, this trend. So, okay, like, this relates to a lot of things that I've heard going around. And I guess the main takeaway from this is that, the hiring is apparently going to get harder and harder. And the years of experience of practicing software engineers is dropping overall. Like every year, sort of the cumulative years of experience, if you just took a random developer out of a pool, is getting smaller and smaller. And we have to look forward to a tidal wave of newcomers entering our profession, and it's not going to get any better. It's just going to keep on picking up speed. So actually, I have an interesting quote. This is from an article published in the Communications of the ACM in January of 2018. This is just a quote. This is about these new development jobs, basically. New frameworks are lowering the barrier to entry, says the founder of a coding boot camp in Tennessee called Code2TN. It's a far cry from the days when you had to learn the syntax of several programming languages to build useful software. Rather than typing these 7 lines of code to get a menu or pop down, you just download the framework from a code base that allows you to do that in a simpler way, he explains. Frameworks are taking the hard work that developers prided themselves on out of the equation. So if you just use a framework, you have to do less work, and you can give this to people with less and less experience. They don't have to do as much work to get things done anymore. That's great, and it's also just worth ruminating on for a second. Another interesting point that I found in a lot of these articles that I had been digging around in for more numbers. These are quotes. I'm not making this up. So it turns out that companies are struggling with developer burnout. I think that's not a surprise. We hear about burnout more and more. If you develop software, you know somebody, or you yourself have been burnt out. But to quote this article, this U.S. tech talent shortage article, unable to fill tech vacancies, employers shuffle off additional duties to current employees, which leads to burnout and has a negative impact on local business development. Over 30% of respondents surveyed by Indeed admit that this is an issue that accelerates staff turnover. So people are losing employees because because they don't have enough people to do the job that needs to be done. People are getting extra tasks piled on them, and people are burning out, and people are just leaving. So with companies unable to fill open positions, current employees are expected to fill the gaps. In many cases, this results in employee turnover. Over a third of respondents we surveyed, 36%, said the lack of timely hiring has caused burnout in existing employees and affected their business. So Indeed did a really long, a very big survey, and this is sort of the write-up in response to that. So obviously, increased diversity would help. We know that people who develop software are not, representative of all of society. So, if we actually get more underrepresented minorities in tech, then, clearly we can increase our numbers that way, right? In the U.S., that also means, immigration would be wonderful if we had nice immigration policies, or if they got nicer, right? But clearly that's a solution to this as well. But the point is that, there's this ballooning need, and I don't know exactly how universities or other educational sort of outfits are going to be able to solve this problem, right? However, we can all be very happy that these frameworks exist, and that's really easy to not have a lot of experience and just to plug a few things together, and you don't have a bachelor's degree in computer science, but you just made a web app. So that's great. And also, I want to highlight some research from a colleague of mine at CMU. So he's been studying, actually, there's a lot of people who go around tech conferences and talk about diversity. I really like this because at least he's found, statistically significant, differences in diverse teams. And so there's a study that he did. It's down here if you want to look at it. It was published at Chi in 2015. But, the TLDR of this paper is that there's evidence that software teams that are diverse with respect to gender and or tenure, so the amount of time you've been on the team, they tend to write code faster than teams that are less diverse. That's super cool. There's also a problem. So this is not exactly related, but I'm telling you, just give me a second. You'll see. Losing people is also a problem, right? And it turns out that there's evidence of women or people who identify as women dropping out of open source, at a significant rate. Significantly sooner than their male counterparts. And, this all comes to basically identity, gender identity on the internet. But, there's a pile of research papers, and basically what they've been able to find is that Developers are typically aware of each other's gender, and the first thing that they care about is programming skills, and the very next thing is gender, and then the real name is the third thing. We don't care about your name, but we care about your gender, which is kind of interesting and scary and weird. So, he's finding all kinds of weird stuff, like people have used fake GitHub handles so people wouldn't, would just assume that somebody was male, right? Kind of crazy, but, it goes along with this graph. I just thought that was interesting and exciting. But, the sort of takeaway for this is investing in sort of building what he calls in these papers social capital and fostering informationally diverse teams fixes this issue. And that's the real takeaway here, not like, oh, it's all so sad, everybody. There is a positive point and a positive result, which also say, hey, maybe we should care about these things if we're going to build bigger and more diverse teams, right? We're going to have to. So on to how we build software. So this is going to be a whirlwind, I'm sorry, but deal with it. So we used to have to work hard to convince companies to trust open source software. I think everybody knows that that's not true anymore. And so I'll just give you a quick, whirlwind tour of how this has changed since 2010. So there's a couple of companies. One is called Black Duck. It has now been renamed or whatever, been acquired. It's called Synopsys. It runs an annual survey, and it also scans companies' code bases. They survey around 1,000 companies each year about their open source usage. And in 2010, they found that 39% of companies said that they ran on open source. By 2015, that number was 78%, which is about a 2x increase over 5 years. So, almost 80% of companies by 2015 said that they ran completely on open source. And we're talking around 1,200 or 1,300 companies that they've interviewed. So the point, of course, after seeing these two results is companies are depending more and more on open source software. But and they also did this for a number of reasons. Companies believe that the quality of solutions are better in open source than anything that they buy or build in-house. Features are competitive with things that they buy, and of course the ability to customize and fix. In 2015, 66% of companies, of those 80% of companies that they surveyed, said that they would consider open source options before they would even look at proprietary alternatives. So they're not even going to try something proprietary. They look open source and they don't care about proprietary stuff. So that became the default choice around that, I would say. By 2017, their survey indicated that 60% of companies had increased their open source usage. And the main reason that they all indicated was low cost with no vendor lock-in. And so, as I mentioned, this Synopsys company also scanned code bases of companies. So they scanned 1,100 commercial code bases, and they found that open source components are in 96% of applications that they scanned, and this was in 2018. So this went up, so this basically went from 38% of people self-reporting in 2010 to 96% of people, or of companies rather, after scanning their code bases. Open source components are found in almost all of them. And what's completely insane, and I'm completely shocked by, is that an average of 257 open source components were found per application. So per company, per industrial application, 257 open source components. So yeah, that's pretty striking. In 2017, as a part of this scan, 36% of the code bases that they were scanning was open source components. Did you hear me? 36% of the code base that they scanned was open source. That meant the other, 60% was something that people actually wrote at that company. That's nuts, right? Right, so the point here is many more applications that people are building are actually, open source code. And in 2018, a company called Tidelift also did one of these, scanning lots of companies' code bases and then sort of, developing statistics. And they argue that most applications now are built on top of a foundation of 70% or more open source code. So in 2018, at least according to Tidelift, we can say that only about 20% of the code in an industrial code base is actually custom application code or business logic. 70% is open source software, like Babel, Vue.js, all of these, Jekyll, whatever, all of these things. And then 10% is commodity infrastructure, which is also typically open source, but at least it's separated from, open source libraries and open source like infrastructure, so things like Kubernetes or Linux. But that's nuts. So 20% of what people write nowadays is often gluing together, these components. That's really crazy. So I'm going to make you stare at this slide for a second and think about that. That's completely nuts. So in 2017 and 2018, 2017, 36% of code bases were open source components. In 2018, Synopsys found that 57% of code bases are open source components. And independently, Tidelift found that 60% of code bases are open source. No, that should be 70%. Typo, but 70% as per the last slide. And only 20% is custom application or business logic. That's completely nuts. Right, and this is like something that actually, we've been suggesting that this is a good idea for a long time now. This isn't like, oh my God, how did that happen? So this is just a quote from Mike Krieger, the co-founder of Instagram. He wrote a blog article back in 2011 trying to give startup founders advice. And it was a very popular blog article that a lot of people used as advice. And basically the point was borrow instead of building whenever possible. There are hundreds of fantastic open source projects that have been built through the hard experience of creating and scaling companies, especially around infrastructure and monitoring, that can save you time and let you focus on actually building out your product. This was like 2000, I think this article was maybe, it doesn't say what year it was. I think it was 2018 maybe, or 2017, I'm not sure. What year, I don't know what year Instagram was acquired. Let's just say that it was 2016, I don't know. But the year that Instagram was acquired, it was acquired for $1 billion, and it was a big deal. Everybody blew everybody's mind. And Nadia Eghbal, the woman who wrote the Roads and Bridges report that I think a lot of people have heard of by now, she estimated in this blog article, that if you look at the components or the pieces of software that Instagram reuses in their apps, that you could attribute, if you just broke up like what looks like the percentage of code that is open source and the percentage of code that isn't, you could say at least $143 million of that $1 billion acquisition was delivered via open source components or open source software, which is also mind-blowing. And despite all of this, we know that there are funding concerns. So this is another graph that came out of Tidelift. So Tidelift did a survey over about 1,200 open source developers or maintainers of open source projects, and found that 62% of respondents said that they they were required to financially support their own open source software with their own funds, and they received no external funding at all. And this number makes me very happy, to be honest. 49% of respondents said that their open source project is supported by their employer, which is how it should be, to be honest. But still, 62% is an alarmingly large number of people who are just doing this on the side, and it's really the foundation of all of these apps that companies are building, right? So of course, things can continue to get terrifying if things aren't maintained. We all know this from 2014 when we found out that there was a serious vulnerability in OpenSSL, which we all remember very fondly as Heartbleed. At the time, 2/3 of all web servers were using OpenSSL, and at the same time, OpenSSL was maintained by only a few volunteers. So there was two guys, one named Steve, one named Steven, some other people. Steve Marcus noticed that one contributor, Stephen Henson, was working full-time on OpenSSL. Marcus wanted to know what Stephen Henson did for income, and was shocked to learn that Henson made, a fifth of Marcus's salary. He was just doing some consulting here and there to keep the lights on, but otherwise he was working on OpenSSL full-time. So, and also this was sort of shocking to Marcus because Marcus thought he was, a strong programmer, but that, Henson was like godly. And Henson had been working on OpenSSL since 1998 and was getting this meager, this pauper wage I'd always assumed, this is a quote from Steve Marcus, I'd always assumed, as had the rest of the world, that the OpenSSL team was large, active, and well-resourced. In reality, OpenSSL wasn't even able to support a single person's work. Right, and so the argument here, the point is that we don't often know of infrastructure's funding issues. And I'm not saying that every single project that everybody depends on has this problem, but some do. Right. So Marcus made a remark which I like. I'm looking at you, Fortune 1000 companies, the one who include OpenSSL in your firewall, application, cloud, financial security products that you sell for profit, and or who use it to secure your internal infrastructure and communications, the ones who don't have to fund an in-house team of programmers to wrangle crypto code, and then who nag us for free consulting services when you can't figure out how to use it. The ones who have never lifted a finger to contribute to the open source community that gave you this gift, you know who you are. In addition to that, there's this fun thing called the truck factor. So the minimal number of developers that have to be hit by a truck or quit before a project is incapacitated. There was a research group in Brazil that looked at the 133 most active projects on GitHub and then tried to, from these commits, determine, from the information in the commits, figure out which individual team member, moved the most information to try and compute this truck factor. And they found that 64% of the top 133 projects on GitHub relied on one or two developers to survive. And this is, you're not supposed to be able to read the rows in this table, but it's supposed to just show you the results. So this is the truck factor here. As you can see, more of these projects are in the top 2 rows, which means, the truck factor is 1 or 2. And just to give you some names so that you can see them, truck factor 1, things like SAS or D3 or Grunt or RX Java. Truck factor 2, Netty, Pandas, apparently Clojure and Cassandra. So a bunch of things that people use and have heard of. This is not like the greatest calculation in the world, but it maybe gives us an idea of some of the projects we should be worried about. Whoops. And the point here is it's not all bad. There are projects that also have high truck factors too, so it's okay. I'm not saying that everything in the world is terrible. Projects with high truck factors, of course, are Linux, thankfully, right? Of course, and then there's, I think, where's V8? V8 is in there, of course, right? 18, yep, there it is. That's no surprise. Thank you, Google. But there are several things in here that have reasonably high truck factors, and that's good. And so this is on the heels of those points, this is a point that I want to make that I've learned from the Scala community and also from research. And the point is, ecosystem and community is really everything when it comes to an open source project. There was a paper in 2013 at Uppsala by Leo Meirovich and Ari Rabkin. They looked at a bunch of data, and they basically, so they had almost 600,000 open source projects. They did surveys ranging from having 1,000 respondents to 13,000 respondents, and basically what they wanted to know is if you're going to adopt a programming language, which factors most influence developer decision making. And what they found was that an open source ecosystem is basically the most important factor. So these are the results, right? And this is the percentage of respondents here. So from 0 to 80%. And green is the overall, and then they broke it up into 2 different groups, one for large companies and one for small companies. As you can see, extending existing code and already used in the group is obviously more important for big companies, but still for everybody, the fact that there exist open source libraries for a programming language is literally the most important thing. So that's the ecosystem point there, is that there has to be an ecosystem. Oops. Yeah, so ultimately the point, just to quote them, through multiple surveys, we saw that developers value open source libraries as the dominant factor in choosing programming languages. Social factors not tied to intrinsic language features, such as existing personal or team experience, also rate highly. This all relates back to a community. If you have a big ecosystem of libraries, that means you have a vibrant community usually. And Tidelift also found this as well. Basically, in 2018, they went to all these companies, and they wanted to know, hey, what's the most important thing to you about open source software? And they found that so it's not just that it's reliable and maintained, which means there's a community maintaining it, but that there is an active community rates basically as highly as the fact that the code is maintained, that there's a community. So basically companies that they went out to responded that having an active community is basically 20% more important than even the popularity of the project. Like that's one of the most important things. So that's interesting. And just 2 quick notes. Again, plugging some research from a colleague of mine, which I found really interesting. So basically, they looked at the PyPy ecosystem. They examined 70,000 packages, and they wanted to understand, like, how different dependency relationships affect, what kind of relationships between different packages, affected survivability, that this package would survive, long term. Things that they found that were very shocking. Well, I guess this isn't super shocking upon retrospect, is that something that has a lot of transitive downstream dependencies actually has a survivability hit. So, the reason for this, when doing interviews with developers, is that when you have a package that it transitively depends on something like NumPy, that's bad for NumPy because people down here are more willing to complain and less likely to fix because they're sort of disconnected very far from this project. And this amounts to basically death by 1,000 paper cuts, as they kind of allude to in at least one of their talks. And another thing that I find completely shocking and not what I would have guessed, commercial involvement is harmful, very harmful. So in their survival models, they found that early stage involvement of a company hit survival by 51%. Basically, it's nice, and from the interviews they found that, okay, well, companies can provide more resources, they can withdraw at any time, and sometimes they completely kill and cripple projects that way. Okay, so what does all of that mean? So community ecosystem are among the most important factors to open source project success. And to stay alive, there's got to be a relentless focus on growing that community and that ecosystem, and it's really hard work. It's something that we don't really currently recognize as an important part of keeping an open source project alive. So on that note, I'd like to remind you that I've iterated through 3 seemingly unrelated topics, right? But I swear they're related. And just to summarize, what these topics were. So how we build software nowadays. So what we actually do when we sit down to build an app, the common infrastructure and tools that we all depend on, so the stuff that's open source, and what software engineers should know, how much experience they have, and who they are. Basically, what do we think a software engineer is? Whoops, that was, we saw 3 areas. So there's a list of points. If you read carefully, you'll see that I kept on putting in here that we're getting a lot of newcomers because I think we shouldn't forget that point. And they don't seem super related, but they kind of are. So the first is, yes, we're getting a lot of newcomers. Those newcomers don't necessarily all have to have fancy CS degrees. Maybe they don't need one because, as we saw through some anecdotal evidence, right, like these these analyses of large code bases and, random interviews and articles here and there, frameworks are really important. I also have seen this time and time again at every company I've been involved with. Depending on frameworks and, the more frameworks, the better, right? So that more people can be productive faster. And I've heard a lot that, this is great for newcomers, not just in these articles. So, maybe people don't need one of these fancy CS degrees, right? Maybe if everything is just, gluing together frameworks, perhaps you don't need 4 years of formal CS education. Perhaps the people who build those frameworks should have that CS education, but not the people who put them together. Again, we're getting a lot of newcomers. I'm just going to say that one more time, or maybe 2 more times. Another thing to take away, so it sounded dire, some of the points that I'm making, but it's actually not. And this is evidence that we're actually getting good at reuse. We've been talking about reuse for years, right? But this is evidence of actually us being good at this now because we are really good as a community of global engineers at reusing things, which is also kind of nice, right? But these pieces that we're using are largely open source components. And we still have some funding issues with open source components. So corporate subsidy is helping about 49%, but 62% is still self-funded or not funded. And we have a lot of work that we have to do to sort of make this landscape better. And again, we're getting a lot of newcomers. And I'd like to just point out, like I said, this is all related. I know you kind of can't see this bottom point here. So newcomers, we're getting and will keep getting a lot of newcomers across our industry. Applications are becoming actually a majority open source components, and frameworks are being used all over the place. We're gluing together open source components to make new applications nowadays. That's like the status quo. These things are all open source, and open source software continues to struggle with sustainability. So, these things are all related because all of these newcomers are basically gluing together these components as parts of their job, right? And they depend on open source software. And not only do that, but they depend on it being easy to use. Like you can't just, oh, Matt has this Crapple license. Have you seen this? Like just publish something in a zip file and like with no documentation and say, hey, I don't care, right? It's like the ultimate academic publishing license, he says. It's the greatest. You should look this up. It's Crapple, C-R-A-P-L. It's the best. Anyway, like we can't publish the software for people to use like that, right? Because all of these people who have little experience with development, are actually depending on this, for their jobs, and they need to be able to figure out how to use it. They need good documentation and things like that. So, I obviously don't have like the solution for all of this, but I have a few points that I think are really important for us just to be aware of. So as educators, so that would be me and several others. The point is, maybe everyone doesn't have to have a CS degree. Maybe we should be okay with that. Maybe we have to figure out ways for people to more quickly and more affordably learn just enough to become an application developer and reserve like this idea of CS degrees being for the people who build, the components that everybody is reusing. Maybe that's how we should look at it. People that are managers, it's going to be, if it's not already important, it's going to be extremely important very soon that engineers become good mentors. So you can't just hire somebody who is the greatest at getting a bunch of things done in like a 24-hour sprint with, drinking like 12 cans of Monster energy drink, right? Like, it's going to be important, or it's becoming important, that people learn how to mentor each other. Because if we're going to have this onslaught of basically newcomers, we should get better at mentorship sooner than later. And of course, we all need to figure out how to, in my opinion, get better at corporate subsidy. Find ways to allow engineers to give back to the open source that companies depend on. And for people who are practicing engineers and have the fortune of not being a manager, hooray! Mentorship is just something that people should care about. Should drop everything and focus on that, and focus on getting better at it, because we're going to have to deal with it soon. And that's all I have to say. I'm happy to answer questions. I think I'm basically out of time, but we also have a coffee break, so you can come up and talk to me maybe.
But there's time for
Okay, cool. Are you alarmed and angry at me? Hello.
Hi. So one of the things you talked about is sponsorship.
Yep.
And I assume you mean by that sponsorship that goes to contributors for open source projects?
Sort of. That's a good question. And I could talk about this for a long time, and I actually have even more data points I could just randomly pull up for you. But the point is, there are all kinds of sponsorship and all kinds of ways to pay for an open source project. One is like Patreon, which doesn't work at all. None of that works at all. The thing that actually works, and there's data to back this up, is basically what we call corporate subsidy, which is either a company basically supports an open source project, like they develop it and they open source it. They just keep they welcome developers. They have like a CLA, things like that. Or there's some notion of like, okay, it's open source Fridays, and people contribute to a list of open source projects that the company depends on, right? Like maybe it's not their project in house, but they make pull requests and they try to join the community of those developers that work on that open source project, and that's considered corporate subsidy. So the sponsorship that I mentioned is that one, corporate subsidy.
Okay, thank you.
Thanks for the talk. I was wondering if you found there was a difference in the needs or situation across the scale of the companies that you interviewed in your time with the Scala Center.
Oh my God, that's such a hard question to answer, and there's like no short answer for that. Like, can you? It's too broad.
I'm asking because I would assume that smaller companies are feeling the pinch because they don't have the resources for recruiting and retainment.
So actually, like the only ones that don't seem to be having a dramatic, terrible time is basically like Google, Facebook, and I don't know, whatever else, like Twitter, you know, some of these big sexy companies. Literally everybody else is basically dying. Like it's impossible. I mean, obviously I'm being dramatic when I'm saying they're dying and it's impossible, but the amount of struggle that they have to deal with is significantly different than what like Google and Facebook have to do, because usually they offer these giant salaries. All these students want to do like internships and whatnot at these big companies. It's like a badge of honor if you get, you know, an internship at Google or Facebook or something. So they have less trouble. I can tell you that from talking to them. But literally everybody else has huge problems recruiting. Just finding anybody to do anything, right?
So I'm at the university, and if we look at the people who are like enrolling into computer science degrees, we see that it's not increasing, but just staying steady. Do you have an idea of why
that's also not true, like across the board.
Yeah.
I mean, so I have, you know, some set of data points, right, which is basically the universities that I worked at, and that's 3 right now. In the ones that can limit their enrollment, they do, and they get more selective, which, you know, in the end is the same number of students coming in every year, right? But they end up getting more selective because they get a lot more applicants. US, right? And then, as far as I understand, at EPFL, where I did my PhD and where I started the Scala Center and where I worked at, they were getting more people, but, you know, they also fail people early on because that's how their system works. But they still had more CS students. I don't know what the number was, but class sizes were increasing. So I don't think that's a problem across the board. At a lot of universities I interviewed at, they had, you know, a problem. Maybe a public university had the problem that they couldn't say, hey, I'm going to limit us to only 200 computer science students. They basically had to take whatever a tax-paying student that like grew up in their state that, you know, qualified for the computer science program into the computer science program, and then could have 1,100 students, you know, when 3 years ago they had 600. I think that was the situation at Northeastern, even though they're private. So I think it's really different all over the place. At least in the US, there's really an asymptote, kind of. I mean, maybe not asymptote, but you know what I mean. Yeah. It'd be great if it was an asymptote.
Most of your data points were coming from US sources.
Yeah,
you
I know.
repeated that all over.
I know.
Do you know whether it's representative of the global situation or not, or
So
maybe a bit?
I was actually curious, but the main problem that I had was that I didn't know where to look for this data. Like, you know, the US is a big country. It has a majority of the computing jobs. So, and they have a nice like bureau for collecting this information. I don't know where I could do that globally, is my problem. So I would love to, but I have no idea where I could get that data.
But do you have a feeling it's representative or no idea?
I have no idea.
Okay.
Because I think it's completely different in like India than it is in Europe, right? In terms of, you know, the jobs and who's graduating and whatever.
Hi, I missed part of your talk, so sorry if you
Okay.
already covered this. But so there are a lot of newcomers to the field, but what do you think is the right way to welcome these people? Do you think universities are doing a good job, or these boot camps are doing a good job?
So I think that right now, if you're going to get an entry-level job as a software developer, at least in the US, you should have come out of a university or a boot camp. Like that's sort of usually the credentials that you need. And the slides at the beginning, which were showing like all of, you know, the need that we're going to have very soon, tried to say, hey, look, even though, you know, we have all these boot camps and these universities putting people out, it's still not enough. So what do we do about it? I'm not exactly sure. I just can say it really doesn't look like universities are going to be able, and coding boot camps are going to be able to fill the need that we're going to have. But some points that I tried to make were, hey, you know, it turns out that diversity is actually helpful. Like there's this, at least this one study, which says, hey, people are writing code faster when they're informationally diverse and there's gender diversity. So maybe we can try to get better at that, of course. And then another point, you know, is that there's all of these frameworks and things that people are using now instead of like writing things from scratch. So, you know, maybe the point is that we don't need people with like full CS educations, and maybe, you know, there's some middle ground, like a coding boot camp or something that more people can find that's, you know, attainable, to give them just like the skills they need to glue components together, but not to implement these components. Sort of, these are the speculations that I'm trying to make. I don't have a solution though. I'm just like, oh, this seems to be a problem, everybody. Did you see this? This is a problem. That's sort of my whole point. All right. Thank you.